Rewarded me and who always work very hard to make me look good. I'm humbled to be honored by this foundation and thank the members of the board for selecting me for this honor, and I also thank the foundation for carrying on the vision of an extraordinary person. Indeed, we've come a long way since Clarke's seminal publication of extraterrestrial relays in the October 1945 edition of The Wireless World, which combined the then nascent technologies of rocketry, wireless communications, and radar to envision geostationary orbiting platforms that could provide worldwide communications coverage, and as he put it, for all possible types of service, noting them as broadcast television, telephony, and high-speed facsimile, or what we know today as data. Consider further that he predicted ground-receiving parabolic antennas about 1 foot in diameter and other basic system parameters of radio and electrical power when there was really no direct evidence at that time of radio waves passing between the surface of the Earth and outer space. Rockets were not capable of launching objects into orbits, and space itself was still largely a mystery. Fast forward to today, a mere generation away from that time, a multi-billion-dollar satellite industry delivers television, voice, and data services worldwide, as Clarke predicted, in a myriad of ways that no visionary, not even him, could possibly have conceived, and that continue to unfold before us every day. The communication satellite is indeed a machine that has changed the world, one of the major engineering achievements of the 20th century. Let me give you just a few examples of how radically communication satellites have changed our lives. In 1914, the British explorer Ernest Shackleton had his ship, the Endeavour, become icebound in the Antarctic. The ship eventually had to be abandoned, and his crew spent 3 years on a small Antarctic island before they were rescued. If this happened today, Shackleton could merely take his satellite phone, call London, ask for a rescue, and then call his wife and tell her he'd be coming home late. Somerset Maugham wrote of a British diplomat in Africa who received 1 year of the London Times in the annual provisioning shipment. Each day, he would carefully read the day's news late by exactly 1 year. Today, obviously, he could watch CNN or BBC and instantly find out what was going on in the world. And obviously, more recently, all of us watched the events in Egypt and the Middle East live and followed the fall of the leaders as it occurred. The people in these countries could not be kept in the dark, as TV broadcasts and satellite access to the internet thwarted all the efforts of dictators to censor and suppress information. More profoundly, there are no longer distant places. With global satellite coverage, billions of people all over the world can receive news, sports, or entertainment content virtually anywhere on the planet and either see it as it happens or time shift it to watch it at their convenience and have it delivered over the internet to wherever they may be on a myriad of mobile devices beyond fixed televisions and in high definition. And so, how did we get here since Arthur's famous prediction? There are far too many stories to tell and people to recognize in the short time tonight. But let me relate some key milestones in my experience. At Hughes Aircraft Company in California, it got started with the cancellation of the F-108 program in the late 50s. Hughes had grown rapidly in the 50s, but was now confronted with the choice of layoffs or diversification. Harold Rosen, a brilliant engineer at Hughes, had an idea for diversification. Why not geostationary communication satellites? The Russian scientist Konstantin Tsiolkovsky defined the geostationary orbit in 1895. At an altitude of 22,300 miles, a satellite in equatorial orbit would have a period of 24 hours and would appear stationary to any observer on Earth. In 1945, Arthur C. Clarke postulated that 3 such satellites could be space stations with television repeaters and could cover the entire Earth. Of course, in 1945, such a system was impractical, but in 1957, the Soviets launched Sputnik and began the space race. The US scrambled to develop launch vehicles and satellites, and communication satellites were quickly identified as an important potential application to space. And Harold Rosen and his team came up with some innovative ideas at that time to make a geosynchronous communication satellite practical. The central idea of the Rosen team was to use a cylindrically shaped satellite which was spun about its axis to provide gyroscopic stability, resulting in President Kennedy's historic phone call in 1963 to the President of Nigeria over SYNCOM, the name given to the first Hughes satellite. It was the early 70s when I first took the plunge and joined a small band of passionate people who had started Digital Communications Corporation in a Rockville garage, and it was a real garage. It was their passion that inspired me to make the leap. It certainly wasn't the clarity of their business plan or any superbly crafted spreadsheet. I don't actually remember even seeing one. Our collective energy and focus was on a single goal: new networking technologies. I firmly believed in my gut that we could do it, although at the time I honestly wasn't sure what it was, and I certainly didn't think it would take 10 to 12 years to figure it out. Inventing the VSAT system and winning Walmart as our first customer turned out to be it, and it put little DCC on the path to becoming Hughes Network Systems, today's global leader in satellite broadband technology and services. At the time, our challenge was to take advantages of satellites' ubiquitous coverage and effectively compete with conventional terrestrial networks in connecting the hundreds of Sam Walton's burgeoning stores and distribution centers across rural America. Using our best overhead slides, we didn't have PowerPoints those days, and engineering capabilities, we convinced Sam and his team that not only could we do it at a lower cost than using wires, but in addition, he could use satellite video conferencing capabilities to review business progress with each of his managers at his convenience. That convinced him to try it, and the rest is history. A few years ago, Fortune magazine named that business decision one of the 25 most strategic of the 20th century. And it gave an emerging mass market retailer a competitive edge through more accurate and rapid information processing to better manage inventories and to hold store managers, more importantly for Sam, accountable through eyeball-to-eyeball contact, albeit over video monitors. Not only did this launch our little company, it launched the Satellite Enterprise Networks business, which today serves global organizations in virtually all sectors, from retail, oil, gas, to automotive, hospitality, and government. However, the big game changer for Hughes and for the satellite industry has been the consumer market, which started in the mid-90s with direct-to-home satellite TV services. I still recall early planning meetings with our parent Hughes Electronics when we confirmed that we could build compact, low-cost receivers to operate with high-efficiency, high-power communication satellites to make DTH services viable. Before these breakthroughs, it required large antennas and extensive real estate to receive signals from the early communication satellites. And it has led to the unprecedented success of DirecTV and Dish, who today serve over 30 million subscribers and have a combined market cap of over $50 billion. Which brings me to how we started our highly successful broadband satellite internet service for consumers, Hughes Net. True to form, it was born of some novel thinking by a handful of dedicated people when few believed it would be a viable business. The bigger questions were the size of the satellite internet market itself and the risks in shifting to a consumer service-oriented business from our heritage as a technology innovator. Literally all parts of the company had to get involved and adapt to the change, from engineering to build an affordable, high-performance subscriber platform, manufacturing to build a high-volume production line, sales marketing to build the dealer and installation channels, and customer care to establish accurate billing and support systems. In truth, it wasn't a smooth ride, and required a significant investment, but the project survived despite numerous setbacks and many critical moments when only the complete belief and commitment of the team kept it going. And it helped galvanize the company, transforming us from a technology innovator and manufacturer to become a world-leading service and technology provider. The results today speak for themselves. Hughes Net is the #1 consumer satellite service in North America, with over 630,000 subscribers at last count, 15 to 20% year-on-year growth for the past 5 years, despite a weak economy, and the main engine driving Hughes' profitability. Affordable small satellite internet for consumers is indeed helping close the so-called digital divide, and its success in North America is now being followed in Europe, Middle East, and with more major satellite investments in Australia, Russia, Asia, and Latin America. Limited ability to pay by individuals hasn't stopped growth in the developing economies like India. For example, where a satellite kiosk pay-as-you-go model is being built out in tens of thousands of rural communities. People can download distance learning and make voice-over IP calls when and as they can afford, or receive much-needed e-governance services. And let's not forget the benefit to the local shop owner who can boost his revenue as a local broadband internet service provider, needing only to make a small government-subsidized investment in the dish and some PCs. Talk about grassroots development. Arthur would surely be proud to see it. Looking forward, obviously, technology will keep advancing, and this will lead to bigger and more powerful satellites. Today's Jupiter 1 will have capacity of over 100 gigabits. I expect in the next 10 years, we'll see satellites with capacities of a terabit and more. VSAT designs will see chipsets of over 100 million gates. And together with these powerful satellites and powerful VSATs, we should see the enabling of some awesome apps and throughputs rivaling many terrestrial systems. Finally, thank you to the Foundation for continuing Arthur's vision. I'm certain he would agree that our collective reward is in knowing we can make the world a better place by transforming communications and helping how people work, learn, and play. Thank you very much.